Yeah, or no?
Hello, everyone. How are we doing today? Um, we are back for the continuation of the series Automating AKS Cluster Deployment. And I'm sure you all found that series quite interesting, right? So today we're going to be, what's the word I should use? Fulfilling our promise to pick up the um, practical session. Today is going to be a practical session, and we are going to be, diving deep into AKS and how you can, automate your deployment, how you can deploy with your pipeline. This is actually to give you a general view, right? But before I kick off, I would like to do the honors and do some kind of introduction so you know who and who we have in the house today. Of course, my name is none other than Promise Uche Onwachku. I'm a senior DevOps engineer, also a Microsoft MVP. And with me in the house, I also have awesome senior consultants, senior DevOps engineers who are going to be taking us on this journey today. The first person I would like to introduce is none other than Chidebere Ugu, who is also a colleague of mine, someone I have worked with in the past, would I say 8 years, thereabouts. And of course, he knows his stuff. He's been in this field for a while, worked with awesome companies, and still has that desire to share his knowledge. Yes, yeah. Please welcome Chidebere Ugo. Chidebere, do you have one or two things to say?
Yeah, thank you, Promise, for the awesome introduction. So today, generally, we'll be having a hands-on experience on deploying a Kubernetes application to Kubernetes cluster. So thank you so much and stay tuned.
Awesome. Thank you very much, Chidebere. Yes, I also have with me on the session today none other than a very good friend of mine and also a colleague of mine, Ihe Anachochukwu. We've known for a couple of years now, maybe 8 years thereabouts, in our journey back in the days with Microsoft. And of course, we've still kept the touch. We've still been doing wonderful and great things. And of course, Nacho has some, you know, years of experiences he's built. And he's normally always wanting to share, always wanting to give, always wanting to, let people into the insight of this knowledge he has. So he's going to also be leading the session with us today. He's none other than Iheana Chochukwu. Iheana, do you have a word for us today? Just a short intro.
Thank you very much for this opportunity to share knowledge and also gain some along the way. I'm glad to be here.
Awesome, awesome, awesome. All right. For those of you who were not privy to the last topic we shared, this was the topic we spoke about automating AKS cluster deployment. And of course, to give an idea, or let me say a short run through of what we discussed during this session, we generally spoke about how you go about automating your cluster deployment with making use of tools like Terraform. How do you scale your AKS cluster? How do you update your AKS cluster? And what are the automation benefits? Right? If you remember clearly, we spoke about, I mean, in this world of, I would say, automation, in this present day of automation, one of the tools you really want to have at the back of your palms is Terraform. I'm not saying it's the only tool, but this tool helps you to be able to, have a code base for all infrastructures you have in your environment. And the beautiful thing about this is even if you have previously deployed this infrastructure, you can always import them into your Terraform state files, right? So that's the beautiful thing about this. And of course, when you have a code base for every infrastructure you have on your system, this helps you to always be in that avenue to replicate the system or the infrastructure anytime, any day there's a downtime or you need to deploy in a new environment. Terraform is your go-to thing to make use of. And of course, we spoke about AKS being an awesome, wonderful application. Microsoft also has this managed cluster service called the Azure Kubernetes service. And in here, you can actually deploy your applications, you can scale them, you can monitor what's happening in your applications, you can take logs on the pods running, how they are behaving, how they are making use of the resources which you are using to run those applications. So quite an interesting, I would say, products that Microsoft has, built for us. Also, we spoke about how do you update your AKS cluster. Say, for instance, maybe there's um, uh, a patch you need to do. How do you go about that? How do you configure that particular application, Kubernetes cluster? So these were some of the topics we focused on in our last session. And we promised you that this time around, we are going to focus on the practicality itself, show do a simple demo just to introduce you into Azure Kubernetes service and how you can do a simple deployment into your cluster and then see how this application is behaving, right? So let me not waste much time, and I will just hand over to my colleague Chideberegu, who will give us some more insights into um, how you can actually do a simple AKS deployment on your Kubernetes cluster. Hello, Chidebere. Yes, you can
Yeah,
proceed.
hello. Okay. Thank you so much for this wonderful intro, Promise. So basically, today we'll be having a walkthrough on deploying a simple application to AKS cluster provisioned on Azure. On our previous session, as Promise has rightly introduced, we did a practical session of deploying a AKS cluster and a container registry using Terraform. So today what we'll be doing will be to deploy a sample application to the AKS cluster just to show a walkthrough on how you can now utilize the AKS cluster you've deployed to manage applications, any kind of application. But for the purpose of this session, we are using a simple .NET application to demonstrate that. So I'll be going ahead to share my screen to give a walkthrough of the code structure that we have. Then before we proceed to the pipeline session. Please let me know once you can see my screen.
Yes, I can see
Yes, I
you.
can see your screen.
Okay, good. So here is a sample code structure that we'll be using today. As I said, a simple .NET application, Hello World app, and then we dockerize the application and then wrote a YAML file to deploy that to via Azure CI/CD pipeline to Kubernetes cluster already deployed on Azure. So first, I will start to explain the code structure. So what we have here basically is the application itself. That is a sample or a sample web application, a .NET application. Then we have the manifest. This manifest file will help us to deploy the AKS to deploy the application to the AKS cluster. And then we have the Docker file. This Docker file we use to Dockerize this application, push the image to Docker Hub or Container Registry. But for the purpose of this, we use Docker Hub on this. Then the Azure pipeline file, which we use to automate the deployment via Azure DevOps pipeline to Azure portal. So first, I will start with the application on the Docker file. So on the application, this is just a sample .NET application, which basically one can decide to deploy any kind of application depending on your desired programming language. So I will not go more details into explaining the code for the application, because each individual might decide to either write a Python for the application, a Node.js, or any preferred programming language. So the purpose of this, as infrastructure automation engineers, I will explain the Dockerization, putting that in a container and then automating the deployment. So, and that will take me to the Docker file. So this is the Docker file that we use to containerize this application. So I'll explain each bit of this so that you understand how you can put the entire application into a container and push that to your desired container registry, or even if it is a manual deployment, you can deploy the image directly from your machine once it is Dockerized. So now, starting from this, we have uh, the first two lines from MCR Microsoft.NET SDK Software Development Kit version 8. So this is a build image. If you're building a .NET application, you have to select your base image that you use to build the application. Then after you've selected your base image, the web API, the working directory, is selecting the file, the folder where your application files are. In a situation whereby maybe you have a Node.js app or different kind of programming language, once you have put everything in a folder, then you specify the working directory where this Docker, once it's being built, will search for the application to containerize. Then the second stage is you copy the CS project. In a .NET project per se, CS project is the main replica of everything that will happen within that applications. So it has all the dependencies. So we'll copy that, and then as we copy that, the next is to run a .NET restore. So the .NET restore will just download and catches all the dependencies that you have already specified within this CS project, because within your CS project, you have all the dependencies that the application will need. So once you run the .NET restore, it will download all those dependencies and catch them for immediate use. Then the third stage we have is to copy now the entire application. Just note that this first copy only copy this CS project that will capture or mirror the dependencies. The second copy will copy the entire file, so which contains every other maybe if you have both front end and back end integrated in one file. So this copy will now copy the entire file to be built, and then when you run a .NET publish, so it will compile the entire application. So this .NET publish, it will compile the application and release that as an output. Just like when you are building your pipeline, after building, you export the the TF plan to TF plan.output, or maybe as an artifact to be reusable. Then the second stage for this, you still make reference to the base image. The excess of this second stage is to copy out the result of this build Dockerization output. So you select your base image, which is at the same time as this, but you know the difference. This is to build the Docker image, and this is the runtime. Use this as a runtime. So you also reference the folder for this entire application, and then you copy. You have a third copy. This third copy now is to copy the output of this build. So just take note of the three copies we have here. The first is to copy the CS project, which has the dependencies, and then run a restore that will download them. Then the second copy is to copy the entire file and then build and publish that as an output. And then the third copy is now to copy the build artifact and then you can now save that to be used or to deploy to any of your preferred environment. But for the purpose of this, you are using AKS cluster. So the last in this Docker file is an entry point. So this a kind of specify the entry points for the application or the commands to be run when the container or the image starts. So the structure of your Docker file depends on the programming language you are using. But for this is just a .NET, a simple .NET app. So it might vary depending on what you want to achieve or the kind of application or language you are using. So that will now take me to the second file, which is a web Web API deployment.yaml. This is the Kubernetes manifest file. For you to be able to deploy a Kubernetes application, you will have a manifest file. This manifest file will specify the namespaces, the pods, the replica sets, and all the requirements for the application to be deployed to Kubernetes cluster. So first, we will have to specify the API version. So this API version is used in every core Kubernetes resources. Then the second is the kind. So this is a kind of a namespace. So it describes the resource type as a namespace. So which with a namespace, it isolates them, all the resources you have in AKS in namespaces. So you can easily track each particular deployment or each particular namespace and do your troubleshooting or whatever in there. Then, well, the second stage is the API version for the deployment. So this deployment now you have to specify the metadata. The kind is deployment. Notice that the kind for this is the namespace, which isolates your resources. The kind for this is the deployment, which specifies the action to be performed here that you want to deploy this app. And then you start to specify different other parameters that will be needed by the app. First is like the metadata or the placeholder for the name, the namespace, and other variables that you need for the app. Then the specification for the application. For instance, here we have two replicas. So in some scenarios, you can put that to 4, 3, or depending on the number of replicas you want your app to have. Then you can also put some labels to label your app so that it will ease troubleshooting or tinting of your images and the rest. Then on the container, you specify the URL for the container. So as you can see on this image, you have the repository URL. That is the repository URL where the image has been pushed. Remember in Dockerfile, after building it, then you have to push it to a container registry, either Azure Container Registry, Docker Hub, or so. So this specifies where the image is located. And then the container port specifies the port you want to be open, how to access that image when deployed. I will explain this repository URL during the time of this Azure pipeline, because during the pipeline, you see how the image is being pushed to respective container registries, either Docker Hub or Azure Container Registry. So again, you have the API service for the third time, which is the kind of service. So this specifies that you are deploying this as a service. Once you make a deployment as a service, it automatically provision all the networking resources that will be needed by that application. So you don't need to do any manual intervention or so. However, within your Kubernetes deployment, you can still customize some of your networkings, preferences, energy, and the rest. But with this service, it will just give you a default network settings and other net connectivity dependencies for the app. And then you specify the protocol, the port number that you want to use to access it, and load balancing. this load balancing automates routing. Let's say we have all these different replicas or so. The load balancing will automate traffic to different of your applications, so different representation of your applications. Then to get to this repository URL where the image is, then I'll be explaining the Azure pipeline YAML where the image is being built, pushed to a desired container registry, and then second stage will be to pull that image from that container registry and now deploy that to AKS environment. So please, as we move, if you have question, you can just jot it down. I'm rounding up, and then we'll take your questions, please. So on the YAML file for the deployment, first we have our triggers. So like I explained in the previous session we had when we deployed the Kubernetes cluster and container registry. So you specify a branch. This branch entails each branch that you specify here shows that when there is a push on that particular branch, it will automate the pipeline to deploy. It will trigger deployment. Though for this section, we're not pushing any new thing, so we can do a manual deployment. We'll trigger that manually. But after that, if there's any new changes in this, it will, with this main, any new changes to main branch, it will automatically trigger the deployment of the pipeline. Then the pool agent. On the previous session, I've already explained this. And then the pool agent is just a VM. In Azure DevOps environment, we have different pool agents. We have a Microsoft provision and managed agent. That is Azure Pipeline agent. Then you have a self-hosted agent. So this is a self-hosted agent. The essence of using a self-hosted agent is to you can segregate your security architecture and manage all the dependencies yourself. And also it helps to run concurrent jobs on your pipeline without much delay. So the variables that will be needed. Here we have our repository URL. So this is the Docker Hub because the image is pushed to Docker Hub, and then the repository and the name of the app. So if you check this Docker Hub URL, you will see the image after build, that the image will be deposited in there. So with a tag name build ID, the essence of build ID is like a versioning. So once there is a build ID on it, if you do another run and build another image of this, it will give it a different build ID. Then you will be able to revert to previous IDs also in case if there is maybe any issue in a current deployment. So we have container registry service connection. So this is a service connection on Azure DevOps that has visibility between Azure DevOps environment and Azure Portal to be able to provision resources on Azure Portal via Azure DevOps. So we have the Kubernetes service connection, which is this as well. So this has a service connection to pull image to Docker Hub, and this has a connection to deploy image to AKS on Azure environment, and the app name specified. Then that takes me to on our previous session. I quickly gave explanation on you can put this in just a variable group on Azure DevOps environment, and then just specify the variable group, and then it will automate picking of all the variables in that group. Then on the first stage, what we have on the first stage is build and push. That is to build the Docker image and then push it to container registry or Docker Hub. So we display name. So the access of this is this container registry service connection. So this is the service connection for the container registry. This is the repository URL that houses the image, and then the command here, which is the major stake, is to build and push. So it will pick the image, it will pick the Docker file from here, which is already specified, build that image, and then push that to this repository URL. And then The second task here will be to copy this build result, copy this is the source folder. So it will copy all these files from the working directory and then push it to artifacts directory. So what is the content of the copy? The content of the copy will be everything. Once we see a star specified on a code block, it signifies all in most cases. So all YAML files here, which the first one is the manifest for the Kubernetes deployment, and second is this pipeline file that I'm explaining now. It will copy all this and push to staging artifacts directory. And then the second task within this stage one will be to publish that artifact so that it will be reusable by another stage of this pipeline. So it will pick this, build and publish the artifacts. So it will pick this build as factory staging directory, which is specified here as the target folder. And then the published location will be on the container. So making it ready to be used in deployment stage. So here on the deployment stage, we specify the your deployment, and then this deployment depends on the previous stage, which is build and push. So which means if the first stage fails, this will not work. It will fail as well because it depends on the previous one. So deploy to which environment? Dev environment. And then a few other parameters that will specify the download the build artifacts, the current build type, which is just from the previous result, then the name of the artifacts in that directory, the YAML files to be picked, which entails the pipeline YAML file and the Kubernetes manifest. Then the directory, that's the system artifact directory, that's the target part where this will now reside, ready to move to Kubernetes cluster. Then here is the second task within this deploy stage, which will be to replace token. So with this replace token, it will gather all the variables, update all the variables that are already specified and before deployment. And the target file for this input will be the manifest deployment file, which is this. So remember that in this manifest, we have specified the replica, the port numbers, and the rest. So it will pick all these variables already specified here and then validate it. That is to confirm that the scripts are right. And then let me go down a bit. Yeah, this to evaluate. This YQ command is to validate that the script works. So once it evaluates that and validates that the script is fine, then the next task is to install dependencies, and the dependencies needed here is kubectl. So this will install the latest version of kubectl, and then the last task will be to deploy that. After all this information is gathered, it will now deploy to a Kubernetes cluster. So there is specifying again the manifest file that has all the configuration for the app to be deployed, and then the repository URL for the image that you have already pushed and the tag name. So this with this, it will now deploy with all these specified environmental variables to your Kubernetes clusters. So that will be all from my side for now. I will be handing over to my colleague Nacho to do the actual deployment from Azure DevOps environment, and then any question you will have, then we drop it for us. Thank you.
Awesome. Thank you very much, Chidibiri, for it. I think, Nacho, You
Yeah,
can please.
yeah, I was muted.
Okay.
Thank you very much, Chidi, for that. That was really detailed and felt like you went through everything thoroughly. So I'll just round this off really.
Okay.
Yeah, we'll come to just to run that same file he has been showing. Really, we have our code here in our repository. And what we just intend to do is to build up from the pipeline file workflow here that Chidi has thoroughly explained to us. So we'll just see this run quickly. And of course, we already have that in place actually. So what we did was we created a new pipeline and we selected this YAML file basically, and we have that in place. So to deploy this, we'll just simply run our pipeline. I would expect you to go through each and every step here. So flowing with the flow we have here, we expect it to do all the job that it has been specified to do right from point A, which would be, of course, to build the Docker image, you know, build a Docker image from the Docker file. So basically what that does is it does a Docker image build, okay? Then it reads through the file you have, it reads through the Docker file, specifying all the steps as mentioned here. And if you look at the logs, you see that happening, it happens very fast. But yeah, you see that happening actually, and it pushes this to our container registry, which in this demo, this will be Docker Hub. And of course, it copies that YAML files, making it available to the next stage. Yeah, so in this next stage, we will be expecting to have a series of replace token. What that does is that it allows us to standardize our manifest and allows us to, put the right variables in place in check. So if we look at what we have here, we'll see that we have placeholders. We have placeholders, which basically should allow us to overwrite this file. So I have a more recent branch. So this will allow us to pass in the names dynamically. So what we are doing is that we are having an app of called a web app, and we'll have to pass that name dynamically into the manifest, which is what we did there. We'll also be overwriting the repository URL, like Chidi already explained earlier on. So with this, we will go to the deploy to AKS parts. And we know we have this approval check, which we already discussed in the last demo, where we have a chain manager going there to accept deployments if it meets the required parameters or the required check they must have been checking in place, making sure probably it's gone through lower environments like say BVT, maybe goes through UAT, then we can have maybe something like this in the production environment. So we're going to go through this and just give this a tick, saying it's a good change to go on. So this does the remaining part of the change. It grabs that image from the Docker registry and tries to deploy this. And of course, let's not forget that we have the manifest replacement that would happen at this point with the replace token tags. So that would have replaced those tokens, right? And the validate manifest actually checks if we have a correct syntax of YAML file, and it also displays the final manifest, meaning that it has replaced the variables that needs to be replaced, and what we have there should be the actual manifest to be deployed. So this will install Kubernetes on the host agent, and this makes the deployments go through. That's pick the image from the container registry and deploys to the cluster. So yeah, this has gone through now. So it's really very, once you've understood all my colleague has explained, this is really a very simplest process to go through. And that's the value of automation. So when we go to the cluster, let's see what we have. We try to understand what has happened, if it's what we're actually expecting. So again, we have the workload and we have the web app namespace, which should be ideal where we should find our resources that have been deployed. And we have it. We have the ports, and we have the replica sets. Then the services will actually, allow us to have access to this application and see what it does or make use of the API application. So in this, we just a demo, and we haven't actually aligned to a DNS record. It's just the public IP address. This is by using a load balancer services. It will route you traffic right into the web application in the cluster. So if we click this, we expect to see just a simple message that says, "Hello, Web API containerized application." So this is like a simple message that was put into the application itself from the code, which is defined in the program.cs file. So it's just a simple endpoint that displays this information, really. So this is just, our way of trying to give you a walkthrough how to do a really hello world application, containerize the application, and get it deployed to AKS cluster. So that's really a very quick demo, having all the codes already in place. So gives us time for questioning, or any clarification. So I'll go back to the pipeline here. Any questions?
I haven't heard any from anyone. I haven't seen any messages, but maybe you can continue. If anything comes up, I would definitely bring across to your attention.
Yes, I think that's done for now because the pipeline is already deployed. It has already shown how we can access the sample application deployed also. So if you have question, we just quickly drop that, and then in absence of any question, then we can call it a day.
Um, Also, I mean, maybe I would just give like an interesting review on this. I think this is actually amazing. I mean, the fact that with just a simple click of a button, you can do quite an awesome number of automations. As you can see here on Ihe Anacho's screen, you can see how he's been able to, deploy a namespace, create a namespace, deploy a web service, and also create a service, right? And the interesting thing about this is with your pipeline, you can always update your applications, you can always update your deployments, and at the same time, you can do operational tasks with all of these automation procedures. And that's the interesting thing about it. Also, you can manage all of your, let's say, if you are in a professional environment where you have your dev subscription, your stage subscription, and your pro subscription, you can also manage all of these configurations, making use of your Azure pipeline. So that is one interesting thing. But I see one hand raised up. Joe, can you proceed to ask your question?
So I was just trying to bring up when I tried sending a message, it's saying we are having trouble loading your message. Try refreshing. So I can actually send a message. I just wanted to say thank you very much for the presentation. It was an awesome presentation, and it was at least I got something from it from my own perspective. So thank you very much for your time, guys.
Thank you very much, Joe. Thank you
Yeah,
very much.
control.
Does anyone have any other question or contribution or comments? Yeah, I see Daniel Alamutu's hand raised up. Hello, Daniel. Can you proceed? Daniel, your hand is raised up, or is that maybe a mistake? If it's a mistake, maybe you can proceed to put it down then.
I think he's muted. He must have been talking, probably just talking to himself.
Oh,
Probably.
that's true. That's true.
So if you hear us, you're muted. You can unmute and talk.
That's true. Okay. I mean, I would say quite an interesting one there. Quite an interesting one there. All right. I mean, I think we did cover up, I would say, quite amazing things today. We were able to then take a look at the intro on AKS. We also spoke about we talked through the code base, and then we actually explained how you can, what's the word? How you can implement your the code base making use of an Azure pipeline. And I think that is quite interesting. So, like we promised you, I think we've been able to fulfill our promise, right? Of what's the word? Of talking about how you can actually, um, set up your cluster, do a sample deployment, and test your deployment. So, yeah, if there are any no questions at this moment, I think it's a good time to round up. But before I do, I would just like to ask Chidebere, any last words?
Okay, thank you, Promise, and thank you everyone that found out time to join us today. So we promise to come up soon with some other deep dive into some other topics on Kubernetes and Terraform and CI/CD pipelining, just within the week anyway. Thank you so much
Oh,
for your time.
awesome. Thank you very much, Chidebere. Ihe Nacho, any last words?
Well, thank you very much for joining this session. Yeah, it was a very quite extensive one, and we hope to have more of this series next time. So yeah, come for our next session, be our guest. Let's take you through this journey of microservices. Thank you for joining.
Yeah. Just before we then round up, I think Daniel rejoined and he has a word of
Yes.
hello, Daniel. You
Um.
can proceed.
Hi everyone. Sorry, I was having issue with my mic, so I had to rejoin. I know this is deploying to Azure. My question is, what about if you are deploying the Kubernetes? You are deploying to Kubernetes on premises. How will it be done?
I think you would follow the same procedures anyway, but anyway, what we are trying to do is we are trying to focus on Azure and
Yes, sir.
explain how to actually make these deployments on Azure, right? So Azure is our primary focus for this session. Maybe in other sessions
Yes.
we can give more details on that. But the truth is Kubernetes is a managed service from Azure, right?
Yes,
Also,
sir.
of course, you can run Kubernetes on other platforms, but we wanted to really give you a deep insight on how you can actually make use of the managed AKS cluster and the
Yes, sir.
service itself, right? So, but the thing with Kubernetes is the principles are the same. Even if you're running on, any other platform, the principles remain the same. You need a master server and you need some subset servers that are going to be your control planes. The master server will be your control planes. Then the pods can run on the worker node. You
Okay,
understand?
sir.
So the principles are still the same, but what we are trying to explain here is that Azure helps you to it provides a very simple, a simplified way of running Kubernetes in your environment. You
All
understand?
right. Yes,
Yeah.
sir.
Thank you
Yeah.
very much for that, Daniel.
Yeah.
Thank you.
If I'm to add something to that, really, Kubernetes is a technology that helps us orchestrate our containerized application. So on that regard, it's definitely similar approaches with AKS, EKS, and the other platforms, right? Including
Yes.
including self-hosted on-premise deployments. So the technology is the same thing, the understanding is the same thing, just that you might be having to do more of jobs, like manage more of things that Azure will have managed for you. So just have it in your mind that Kubernetes is exactly similar stuff, but once you want to take on a self-managed architecture, you have more to manage, basically. Okay, so if don't be just trying to tell you, don't be discouraged for the fact that you might not be using AKS, and we're talking about AKS here, right? But
Yeah.
get the understanding of same stuff. And of course, like I mentioned, it's gonna be more work for you because you're gonna be managing the worker nodes, the master nodes yourself, security patches, all of you. Probably even do more of proxy settings, like using Istio and all of that. So it all depends on how you want to go about it, right? But it's definitely the same technology, but you have more work because you are managing it yourself. Okay. So stay along, don't get discouraged, still join us while we explore more of this, okay?
Yes, sir. Thank you very much.
Yeah.
Okay, just in addition to this, my colleagues have said, and a quick one. Um, if actually you want to deploy to your on-premise Kubernetes cluster via a pipeline, as they have mentioned that you just follow the same approach. So the hint that I would like to give you is within that pipeline deployment file, we specified a service connection. So, and that service connection is a line of sight between Azure DevOps environment and Azure portal. So in a illustration whereby you want to run that via Azure DevOps to an on-prem, I don't know how the scenario that you want, but the major thing there is just to set up a secure access that that has visibility between the DevOps environment and the on-premise, a connectivity between the two, an authentication method, and then we follow the same process as my colleagues have explained, and you are fine.
All right, sir. Thank you, sir.
Okay.
Also, I wanted to use the opportunity to mention that in case you haven't joined our groups, in case, and also if you want, if you would like to, also be updated with all the events we are planning and how we are organizing these events, we are asking that do well to join our Meetup page. This is also our LinkedIn page. Do well to also follow us on our LinkedIn page, and that will help you be updated with the events and sessions we are organizing. So if you want to know or you want to be up to date with what we are doing, ensure to follow the LinkedIn page and the Meetup page. I don't know, I'm not able to paste the links on the chat, but that's why I'm actually sharing the screen so that you can be able to see which page is ours. Just search for Azure Infrastructure and DevOps Support Community. Same thing as well, Azure Infrastructure and DevOps Support Community. And yeah, you'll be updated with all of the activities we are working on and planning on. All right, guys. At this point, I think we have actually covered a lot, and I would like to say enjoy your weekend. Thank you all. See you in our next event.
Thank you, guys.
All right.
Thank,
Yeah, bye.
thank you, guys. Bye bye.
Bye bye.
Thank you very much, sir.
All right, you're welcome.